Okay, let's go. Number 1. Saturn's polar hexagon. The year is 1988. You're a planetary scientist at the Jet Propulsion Laboratory in Pasadena, California, and you're looking at images from Voyager 1 and Voyager 2, the twin probes that flew past Saturn in 1980 and 1981. The images from the North Polar region have been sitting in the dataset for 7 years. The resolution wasn't quite sharp enough to interpret confidently. Now it is. You lean closer to the monitor. There is a hexagon on Saturn, not a metaphor for hexagonal cloud patterns, not an approximate shape that your eye rounds into geometry. A perfect, regular, six-sided polygon encircling Saturn's entire North Pole. Each side is approximately 8,600 miles long, which is longer than Earth's full diameter. The hexagon is about 20,000 miles across and roughly 60 miles deep. It rotates. It has persisted in exactly this configuration, with this geometry, for the entire span of time it has been observed. That span now exceeds 35 years, across Voyager, Cassini, and ground-based observation from the 21st century. The corners are sharp, the geometry is consistent. The atmosphere inside the hexagon has a different color from the atmosphere outside it. The wind speed along the hexagonal boundary measures approximately 200 miles per hour, traveling in the precise path of a six-sided figure. Here's where it gets strange. In nature, fluid dynamics produces circles. Storms are circular. Hurricanes are circular. Jupiter's great red spot is elliptical, which is a rounded form. Circular motion is what happens when fluid rotates freely, because the path of least resistance in any rotating fluid system is a curve. The Navier-Stokes equations, which describe how fluids behave, do not predict hexagons. They predict vortices. They predict circles and spirals. A hexagon this large, this persistent, and this geometrically precise is not a structure that fluid physics typically generates. Scientists have reproduced something similar in laboratory experiments. When a rotating cylinder of fluid has a stationary outer ring, hexagonal and other polygonal patterns can emerge at certain rotation speeds. But Saturn's hexagon is not contained inside a cylinder. It is sitting inside a gas giant planet with no hard boundaries, no walls, no container of any kind. The conditions that produce the hexagon aren't fully understood. The mechanism that maintains its geometry across decades of continuous storm activity is not understood. The reason Saturn's southern pole has a circular vortex while its northern pole maintains a hexagon has not been explained. In 2012, as Saturn's seasons shifted and sunlight reached the North Pole for the first time in years of Cassini observation, the hexagon's color changed from blue to gold. The change was caused by photochemical reactions, sunlight altering the chemistry of the atmosphere inside the polygon. This means the hexagon maintains a chemically distinct interior atmosphere, separated from the exterior Saturnian atmosphere by the boundary of its own geometry. A six-sided atmospheric wall that the hexagon draws and holds, without any solid surface to support it, for longer than any human institution has been watching. The Cassini mission spent 13 years orbiting Saturn before its controlled descent into the planet's atmosphere in 2017. It photographed the hexagon thousands of times. It measured the winds, the chemistry, the thermal structure. The documentation is comprehensive. The explanation for why a gas giant planet maintains a mathematically precise six-sided polygon at its north pole is not complete. If they understood the hexagon completely, they would have predicted it. They didn't predict it. They found it, photographed it for 35 years, and are still working out what the solar system is doing and why it chose six sides. Number 2. Pluto's beating heart. The year is 2015. You're a mission scientist on the New Horizons team at the Johns Hopkins University Applied Physics Laboratory, and you're watching data return from a probe that has traveled 3.67 billion miles over 9.5 years to reach a world roughly the size of Russia. New Horizons performs its flyby on July 14th at 7:49 a.m. Eastern Time. It is the fastest human-made object ever launched, traveling at 36,000 miles per hour. It has one chance. A single flyby, no orbit, no second pass. Whatever it captures in the next several hours is all there will ever be, for at least a generation. The images begin returning. On Pluto's surface, visible from approach, is a feature so immediately recognizable that the team names it before the press conference ends. There is a heart on Pluto, a vast, white, heart-shaped feature approximately 1,000 miles across, positioned in the equatorial region, brighter than any surrounding terrain by a dramatic margin. The western half is smoother and more luminous. The team names the full feature Tombaugh Regio in honor of Clyde Tombaugh, who discovered Pluto in 1930. The western heart-shaped section becomes Sputnik Planitia, a nitrogen ice basin roughly the size of Texas. Here's where it gets strange. Sputnik Planitia is not static. The nitrogen ice is actively moving. It convects, rising from below, circulating, and sinking again, driven by heat from beneath and cold from above in a process that produces the rounded, segmented surface pattern visible in high-resolution imagery. The convection cells are 15 to 25 miles across. This is geological activity. This is a world that planetary science, based on everything known about small, distant, cold bodies before 2015, should have been geologically dead for billions of years. Pluto's average surface temperature is approximately negative 380 degrees Fahrenheit. The Sun, from that distance, appears as an exceptionally bright star. The world was expected to be inert, featureless, and finished. Pluto's heart is not decorative. It is driving Pluto's entire atmosphere. The nitrogen evaporates from the ice surface, rises, circulates around the planet, and redeposits on cooler terrain. The heart is a planetary atmospheric engine, generating wind patterns that circle the globe in a regular cycle driven entirely by a single ice feature. Simulations indicate this circulation has persisted for geological timescales. There is also the question of position. Sputnik Planitia sits almost exactly on the tidal axis opposite Pluto's largest moon, Charon, at the precise point on Pluto's surface that faces directly away from Charon's gravitational pull. A massive ice basin at that location is gravitationally preferred. The nitrogen ice is dense enough that Pluto's entire rotational orientation has shifted to keep it there, the planet tilting to put maximum mass at the tidal axis. This process is called true polar wander. The heart chose its position. It tilted a world to suit itself. Before New Horizons, Pluto was declared geologically dead by the reasonable consensus of planetary science. It was also reclassified downward from planet to dwarf planet in 2006. The assumption was inert, cold, and finished. Instead, New Horizons found mountains of water ice rising 11,000 feet, a nitrogen glacier driving global weather, and active geological processes that no model had predicted on a body this small and this far from any meaningful heat source. Radiogenic heating from Pluto's core accounts for some of the internal energy required. The complete energy budget is not resolved. A world declared dead is moving. And if Pluto surprises like that, consider what a moon smaller than Arizona is doing, 887 million miles from the Sunday. Number 3. Enceladus's hidden ocean. The year is 2005. You're a Cassini mission scientist, and the spacecraft has just completed an unexpected close flyby of Saturn's sixth largest moon. Enceladus is a tiny world, barely 313 miles across, smaller than the state of Arizona. Every photograph taken of it shows a surface that is startlingly, impossibly white. The albedo of Enceladus is 0.99. It reflects 99% of the sunlight that strikes it, the highest reflectivity of any confirmed object in the solar system. The surface looks like new snow because something is constantly producing new snow. You're about to find out where it's coming from. Near the South Pole, through a set of fissures in the ice called the Tiger Stripes, Enceladus is erupting. Not lava, water. Geysers of water vapor and ice particles are shooting from the surface at approximately 1,400 miles per hour, extending 500 miles into space. Cassini flies directly through the plumes on subsequent passes. The onboard mass spectrometer samples what's erupting: water, molecular hydrogen, carbon dioxide, methane, complex organic compounds. Silica nanoparticles consistent with hydrothermal activity at temperatures above 194 degrees Fahrenheit. Here's where it gets strange. Enceladus is 887 million miles from the Sunday. At that distance, the Sun delivers almost no heat. Enceladus should be frozen solid all the way to its core. Instead, it has a liquid water ocean beneath its ice shell, estimated at least 6 miles deep and possibly 20 miles deep, with a silicate rock floor heated by hydrothermal vents. Tidal forces from Saturn's gravity flex the moon as it orbits, generating friction, generating heat, keeping the water liquid. The ocean has been liquid for possibly hundreds of millions of years. The molecular hydrogen in the plumes is significant in a way that requires a moment. Molecular hydrogen in a geothermal system is produced by a specific reaction, water interacting with hot rock at high temperature and pressure. The reaction is called serpentinization. On Earth, serpentinization occurs at hydrothermal vent systems on the ocean floor. Those vent systems support entire ecosystems, bacteria, tube worms, shrimp, complete food webs that run entirely on chemical energy rather than sunlight. They exist in total darkness, under crushing pressure, with no connection to photosynthesis. They exist because the chemistry is sufficient. The chemistry at Enceladus's ocean floor appears to be sufficient. Molecular hydrogen is confirmed. Complex organics are confirmed. Liquid water is confirmed. A temperature gradient from cold ocean water to hot vent floor exists, the same energy differential that Earth's deep-sea ecosystems exploit. And unlike Europa's ocean, sealed under 20 miles of ice, Enceladus is ejecting its ocean's chemistry directly into space at 1,400 miles per hour. A spacecraft can sample the ocean without drilling. Cassini did. What NASA and ESA scientists say in published papers is that Enceladus presents potentially habitable conditions. What potentially habitable conditions, maintained for hundreds of millions of years at an active hydrothermal system implies, is something researchers approach with careful, measured language in publication, and rather less careful language in recorded conference conversations. On Earth, wherever the chemistry is right and the energy source exists, life has been found, every time. The condition of habitable has always resolved, on Earth, into inhabited. Whether that pattern holds at Enceladus is a question no instrument has been positioned to answer. Cassini ended its mission in September 2017 when it was directed into Saturn's atmosphere. No spacecraft with life detection instrumentation is currently orbiting Saturn. Enceladus is erupting its ocean into space, and no one is there to catch it. Number 4. Europa's subsurface ocean. The year is 1995. You're a Galileo mission scientist beginning an orbital survey of Jupiter's moon system. Europa is the second of the 4 Galilean moons, the ones Galileo himself identified through a handheld telescope in 1610. It is slightly smaller than Earth's moon. Its surface is covered in ice, crisscrossed by a network of brownish-red lines stretching across the hemisphere like the cracked shell of a hard-boiled egg. It is the smoothest body in the solar system. There are almost no craters. Whatever craters form are quickly erased. The surface is being continuously renewed from below. Galileo's magnetometer begins returning data its designers hadn't anticipated. Europa is generating a magnetic field, not from a solid iron core, but from a layer of electrically conductive fluid near its surface. The only material consistent with the conductivity and depth the data requires is salt water, not ice. Liquid salt water, sitting beneath the ice shell at somewhere between 6 and 19 miles from the surface. The ocean beneath that ice is estimated to contain twice the volume of all of Earth's oceans combined. It has likely been liquid for the age of the solar system. Jupiter's tidal forces maintain the heat, and Jupiter is more massive than Saturn. The forces are stronger, and Europa's ocean is correspondingly older and more stable than Enceladus's. Here's where it gets strange. In 2012, the Hubble Space Telescope imaged what appeared to be water vapor plumes erupting from Europa's south polar region. Hubble confirmed a second detection from the same location in 2019. The plumes extend approximately 100 miles above the surface. And in 2016, NASA's analysis of archived 1997 Galileo data found that the spacecraft may have flown directly through a Europa plume during a low-altitude flyby, without anyone recognizing it at the time. The magnetic and plasma readings from that 1997 pass, reanalyzed 19 years after the fact, fit the profile of a water plume eruption. Europa may have been erupting its ocean in 1997. Galileo flew through the evidence, and nobody knew what they were looking at until nearly 2 decades later. The ocean's composition is unknown, but the surface chemistry leaves fingerprints. Spectroscopic analysis of the reddish-brown material along Europa's lineae, the cracking patterns across the ice, finds complex organic compounds alongside magnesium sulfate and sodium chloride. Salt and organics, compounds that track the movement of fluid from the ocean below through the ice cracks to the surface above. The ocean is pressing against the ice from beneath, leaving its chemistry on the outside. The question is not whether Europa's ocean is habitable. The consensus answer to that question is effectively yes. The ocean is liquid. It is saline. It likely has a rocky floor with hydrothermal activity. It has maintained these conditions for billions of years. The question is whether anything actually used those conditions, whether life, over 4 billion years in a liquid water ocean with chemistry and energy gradients similar to Earth's early seas, had the same results here that it had there. NASA's Europa Clipper mission, launched in October 2024. It is on its way to Jupiter. Arrival is scheduled for 2030. The spacecraft will perform 49 flybys of Europa, sampling whatever the moon is emitting and measuring the ocean through the ice. It carries instruments designed to detect biosignatures in Europa's surface and plumes. Results will arrive in the early 2030s. Whatever the finding is, it will be the most consequential in the history of space exploration in either direction. The ocean has been waiting for 4 billion years. It will wait 5 more. Number 5. Planet 9. The year is 2016. You're a planetary astronomer at the California Institute of Technology, and you've just submitted a paper that will become the most discussed document in planetary science within 24 hours of publication. The office is quiet. It's a normal working Tuesday. The coffee in the mug beside your keyboard has gone cold while you finish the final calculations. Your co-author is Mike Brown, the astronomer whose discovery of the dwarf planet Eris contributed directly to Pluto's reclassification in 2006. Together with Konstantin Batygin, you've analyzed the orbital paths of 6 objects in the outer solar system. These are trans-Neptunian objects, small bodies orbiting the Sun at distances far beyond Neptune. Their orbits, by every reasonable expectation, should be distributed randomly. They are not. The 6 objects share an orbital alignment with a probability of occurring by chance of 0.007%. Their orbits cluster in the same direction, tilted at the same angle relative to the plane of the solar system. Something is organizing them. Something with enough gravitational mass to herd the orbits of multiple independent objects across billions of miles of space into a coherent and persistent pattern. Here's where it gets strange. Your analysis proposes that the only mechanism producing this clustering is an unseen planet, approximately 10 times Earth's mass, orbiting the Sun at a distance between 400 and 800 times Earth's distance from the Sunday. At that distance, it would take between 10,000 and 20,000 years to complete a single orbit. It reflects so little sunlight at that distance that no existing telescope has photographed it, but its gravitational fingerprint is visible in the orbits of every small object it has been quietly reorganizing for the past 4.5 billion years. This planet, if it exists, would be a super-Earth or mini-Neptune, a class of planet extraordinarily common in surveys of other solar systems. It is the most abundant planet type in the observable galaxy. Our solar system does not have one in any orbit we can confirm. Planet 9 may be why solar system formation models consistently predict a planet in this size range that observation says we're missing. The planet is there. It is simply very far from the Sun and very dark. Since 2016, the number of trans-Neptunian objects whose orbits appear consistent with Planet 9's gravitational influence has grown to more than 20. Independent research groups at the University of Michigan, Yale, and institutions in Japan and France have confirmed that the orbital clustering is statistically significant. The search has been conducted using the Subaru telescope in Hawaii, one of the world's largest optical instruments. It has not found Planet 9 yet. The search area is large, and the sky is dark at those distances. If Planet 9 is found, the discovery would require a rewriting of the standard model of solar system formation. It would mean the solar system's architecture has been incorrect in our models for decades. It would raise the question of why Planet 9 orbits so far from the Sunday. The leading origin hypothesis involves a close encounter with another star during the solar system's early history, one that threw a forming planet outward to its current extreme orbit. A near collision between star systems billions of years ago, detectable only now, by its gravitational echo at the system's edge. Planet 9 is either there, massive, cold, dark, and ancient, or the orbital clustering has an explanation no one has yet proposed. Both possibilities are, in their own way, extraordinary. The search continues on every clear night that large telescopes can be pointed at the relevant section of sky. And if a planet that massive can hide in our own system for this long, what else is out there that we've been looking past without knowing it? Number 6. Oumuamua. The year is 2017. You're an astronomer at the Pan-STARRS telescope facility on the summit of Haleakala in Hawaii, and the automated sky survey software has flagged an object. The software continuously scans for near-Earth objects, asteroids and comets, whose trajectories bring them into proximity with Earth. This object is moving faster than any near-Earth object should. The software calculates its path backward through time. It did not originate in our solar system. It came from outside. It is the first confirmed interstellar object ever detected traveling through our solar system. The world's attention will briefly fix on it. The scientists who study it will not move on. The object is named Oumuamua, a Hawaiian word meaning roughly scout or messenger from the distance arriving first. It is approximately 800 feet long. Whether it is cigar-shaped or flat and disc-shaped is uncertain. The rotation data suggests an unusually elongated or flat geometry with no confirmed parallel in any known solar system object. Its surface is dark red, consistent with long-duration exposure to cosmic radiation during interstellar travel. It has no detectable coma, no gas cloud surrounding it, as comets produce when solar heat drives volatile material off the surface, despite passing close enough to the sun that any volatile material should be visibly evaporating. Here's where it gets strange. As Oumuamua recedes from the sun, its acceleration increases, not decreases, increases. An object moving away from the sun's gravitational pull should slow relative to the sun's frame of reference. Oumuamua does the opposite. Something is pushing it. The standard explanation for non-gravitational acceleration in small solar system bodies is outgassing. Volatile material evaporating from the surface provides thrust, the same mechanism that produces comet tails. But Oumuamua has no visible coma. No outgassing was detected during its approach. The Spitzer Space Telescope observed it specifically to search for infrared signatures of evaporation and found none. The acceleration is real and confirmed. The mechanism is unidentified. Several proposals have been published in peer-reviewed journals. Hydrogen icebergs, nitrogen ice fragments, pancake-shaped aggregates of interstellar dust. Each proposal requires physical properties or formation conditions with no established parallel in any observed solar system object. Avi Loeb, who served as chair of Harvard's astronomy department at the time, published a paper and later a book arguing that the most internally consistent explanation for all observed data combined is an artificial object, specifically a light sail, a thin sheet of reflective material that accelerates through radiation pressure from sunlight. A sail thin enough and large enough would explain the non-gravitational acceleration without outgassing, and would explain the unusual geometry the rotation data implies. The scientific community's response was not warm. The underlying data is not disputed. The interpretation is disputed on the grounds that extraordinary claims require extraordinary evidence, and that a natural explanation, however novel, is preferable before all natural candidates are eliminated. That is a reasonable standard. The difficulty is that every natural candidate proposed also requires extraordinary and unobserved properties. The standard is being applied to all options in a situation where none of the options are ordinary. Oumuamua has left the solar system. It will not return. All data that will ever exist about it was collected in 6 weeks. What is fixed in the record: dark red, elongated or disc-shaped, no coma, and an acceleration that no confirmed natural mechanism completely explains. The first interstellar object ever confirmed to have traveled through our solar system visited, behaved in ways physics doesn't fully account for, and left before we could look more closely. Whatever it is already beyond any telescope we have. Number 7. Mars's underground lakes. The year is 2018. You're part of the team operating the Marsis radar instrument aboard the European Space Agency's Mars Express spacecraft, and you've spent 3 years quietly re-examining data that has been sitting in the archive since 2012. Mars Express has been orbiting Mars since 2003, the longest continuously operating spacecraft in Martian orbit. MARSIS sends radar pulses through the Martian surface and measures the reflections, the same technique used by ground-penetrating radar on Earth to locate buried structures, water tables, and geological formations without a single drill stroke. The archived data from the South Polar Layered Deposits, a region where alternating layers of water, ice, and frozen carbon dioxide extend several miles below the surface, contains a reflection that the original processing missed. Not from the surface, not from the layered ice above, but from beneath it, from a depth of approximately 1.5 miles. The reflection is bright and flat. Its reflectivity is higher than any ice, rock, or dry ice layer above it. On Earth, when ground-penetrating radar returns a bright, flat basal reflection beneath an ice sheet, the identification is well established: liquid water. The team runs the analysis. They publish in Science in July 2018. Beneath the south polar ice of Mars, there appears to be a subglacial lake approximately 12 miles across. Here's where it gets strange. At a depth of 1.5 miles beneath the Martian south polar ice, water should not be liquid. Mars's atmosphere is less than 1% as dense as Earth's. Average surface temperatures run approximately -80 degrees Fahrenheit. With no confirmed significant geothermal activity in the polar region, the temperature at depth should be well below freezing. For water to remain liquid there, either the local geothermal heat is higher than current models predict, or the water contains dissolved perchlorate salts at concentrations that depress the freezing point enough to maintain a brine liquid at temperatures approaching -94 degrees Fahrenheit. Perchlorates are found across Martian soil in quantities sufficient to make this explanation physically plausible. In 2020, a follow-up analysis identified 3 additional radar bright zones surrounding the main reflector, consistent with a network of smaller briny lakes around a central body. Then the dispute began. Independent research groups argued the same radar signature could be produced by specific clay minerals or volcanic basalt, not liquid water. The ESA team maintained their interpretation. Both sides published. The data supports both interpretations, and the only way to determine which is correct is to drill through 1.5 miles of Martian polar ice and retrieve a sample. No spacecraft currently at Mars carries drilling equipment approaching that capability. No mission with that capability is funded and in development. What would be found in a liquid water lake that has potentially persisted beneath Martian ice for millions of years? Mars had liquid water at its surface 3 to 4 billion years ago. Its oceans and rivers dried when the planet's magnetic field collapsed and solar winds stripped the atmosphere. But if water retreated underground as the surface became uninhabitable, if perchlorate brines maintained liquid environments deep in the polar regions through that process, then whatever organisms lived in Mars's ancient surface oceans had time to follow the water down. Not fossils preserved in dry rock. Organisms, if they adapted, surviving in cold hypersaline lakes beneath 1.5 miles of ice in a darkness that has lasted longer than complex life has existed on Earth. The radar data exists. The interpretation is disputed. The confirmation requires going there. Going there is not planned. And the next disputed detection happened closer to home, in a planet everyone assumed was simply too hostile to consider. Number 8. Venus's phosphine signal. The year is 2020. You're an astronomer at the University of Cardiff, and outside the window the Welsh sky is overcast in the way it reliably is, nothing visible of anything beyond the clouds. Your team has spent months analyzing data returned from 2 of the world's most powerful radio telescopes, the James Clerk Maxwell Telescope on Haleakala in Hawaii and the ALMA Array in the Atacama Desert of Chile. You've been looking at Venus's upper atmosphere in a specific wavelength band that indicates the presence of phosphine, a molecule consisting of 1 phosphorus atom bonded to 3 hydrogen atoms. Phosphine is significant because of what produces it. On rocky planets, phosphine is destroyed rapidly by sunlight and by oxidizing atmospheric chemistry. It cannot persist unless something is continuously replacing it. On Earth, phosphine is generated in 2 contexts. Industrial manufacturing is the first. Anaerobic microorganisms, bacteria and archaea that live in oxygen-free environments, such as swamps, wetlands, and animal digestive systems, is the second. It is produced by life. Scientists have proposed for decades that detecting phosphine in a planetary atmosphere would constitute a biosignature, chemical evidence of biological processes occurring at scale. Before 2020, no one had found it anywhere other than Earth. Your analysis returns a phosphine concentration of approximately 20 parts per billion, located in Venus's cloud layer at an altitude of roughly 31 miles above the surface. At that altitude, Venus's temperature ranges between 140 and 200 degrees Fahrenheit, and the pressure is comparable to Earth's surface. It is the most Earth-like environment in the solar system outside of Earth. Here's where it gets strange. The team publishes its findings in Nature Astronomy in September 2020. The paper is carefully worded. It does not claim life has been found. It states that phosphine is present at a concentration that cannot be accounted for by any known non-biological process, and that the source of production is unknown. The paper lists every identified abiotic phosphine source: volcanic activity, lightning discharges, photochemical reactions. None produce phosphine in detectable quantities at the relevant Venusian altitude. The team acknowledges that an unidentified atmospheric chemistry could explain the signal, while noting no such chemistry has been proposed or observed. The months that followed were characterized by a level of scientific disagreement unusual even for contested findings. A recalibration of the ALMA dataset reduced the reported phosphine concentration from 20 parts per billion to approximately 1 part per billion. A separate research group argued that the spectral line identified as phosphine might instead be sulfur dioxide, a common Venusian atmospheric compound with an adjacent spectral signature at the observing resolution used. The Cardiff team disputed the reanalysis. Multiple independent groups published analyses both supporting and contradicting the original detection. The original paper was formally corrected. As of 2024, the question is unresolved. Phosphine may be present in Venus's atmosphere at low concentrations that are difficult to distinguish from sulfur dioxide at interplanetary distances. It may not be present at all. Or the original detection was accurate, and the recalibration introduced the error. There is no spacecraft currently at Venus with instrumentation capable of directly sampling the cloud layer. NASA's Da Vinci mission, an atmospheric entry probe designed to descend through Venus's atmosphere and measure its chemistry in situ, is in development with a launch target of 2029 and arrival around 2031. What was detected in 2020 was either a world-altering discovery, managed quietly into a data dispute, or a genuine instrument artifact produced by the limits of remote spectroscopy across interplanetary distances. The data required to settle the question doesn't exist yet. It won't for another decade. The clouds are not giving up their chemistry to anyone who isn't willing to go there. Number 9. The lunar pits. The year is 2009. You're a geologist analyzing imagery from the Japan Aerospace Exploration Agency's Selene lunar orbiter, known as Kaguya, which has been mapping the moon's surface in higher resolution than most prior orbiters. The terrain camera has returned an image from the Marius Hills region, a volcanic plateau on the near side of the moon, and something in it doesn't match anything in the catalog: a shaft. A vertical hole in the lunar surface, roughly 213 feet across, dropping straight into darkness. The floor is visible in images taken at the right sun angle, approximately 260 feet below the surface. The walls are sheer. There is no debris cone at the base that would indicate a meteorite impact. This is not a crater. The material hasn't been thrown outward. Something beneath the surface has simply given way, and whatever was supporting it from below is gone. NASA's Lunar Reconnaissance Orbiter camera, which began its own mapping survey the same year, subsequently identifies similar features across the near side. A pit in Mare Tranquillitatis, the same lunar mare where Apollo 11 landed, measures approximately 330 feet across and opens to a floor roughly 350 feet below the surface. Additional pits appear in Mare Ingenii and other volcanic regions. At least 200 lunar pits have now been catalogued across the near side of the moon. Here's where it gets strange. The pits are not random collapses. They are skylights into lava tubes, the remnants of ancient volcanic channels through which lava once flowed beneath a hardened crust and from which lava subsequently drained, leaving hollow tunnels extending for miles or tens of miles beneath the surface. On Earth, lava tubes exist in Hawaii, the Canary Islands, and Iceland. The largest are perhaps a few hundred feet across. On the Moon, formed in lower gravity and from lower viscosity ancient lava flows, the tubes are vastly larger. Structural models suggest individual lunar lava tubes could be miles wide and hundreds of miles long, large enough to contain a city beneath a stone ceiling hundreds of feet thick. The pits are entry points into that system. The 350-foot shaft in Mare Tranquillitatis drops to a floor that radar analysis and structural modeling suggest is the top of a much larger tunnel network extending beyond what any camera can see. What lies in that network has never been directly observed by any instrument on any mission. In 2023, NASA's Lunar Reconnaissance Orbiter returned detailed thermal imaging of the Mare Tranquillitatis pit. The data showed that the pit's interior maintains a stable temperature of approximately 63 degrees Fahrenheit regardless of the 2-week lunar day or 2-week lunar night above it. On the open lunar surface, temperatures swing between positive 260 degrees Fahrenheit in full sunlight and negative 280 degrees Fahrenheit during the night, a range of 540 degrees. Inside the pit, 63 degrees. Stable. Protected from that temperature swing by hundreds of feet of rock, and from cosmic radiation by the same material. An environment that, if it could be pressurized, would require almost no active thermal management to support human habitation. The implications for lunar exploration are significant enough that NASA's Artemis program has specifically identified lunar pits as priority targets for crewed landing missions. But exploring the tunnel systems beyond the pit floors requires descent equipment no current lunar mission carries. The pits have been photographed from orbit. The tube systems they open onto have never been entered. The Moon has been geologically quiet for approximately 3 billion years. The tubes have been waiting just as long. And whatever our nearest neighbor has been keeping inside them, the first world beyond our own that was supposed to hold no surprises at all, has been keeping it patiently. Number 10. The Solar System's Missing Planets. The year is 2011. You're a planetary scientist at the Southwest Research Institute in San Antonio, Texas, and you're running computer simulations of the solar system itself, not of a specific planet or a specific mission, but of the entire system from the beginning. Your simulations model the first billion years of solar system history, the period of formation, migration, gravitational instability, and gradual settlement that produced the planet arrangement we see today. You run the simulations thousands of times, varying the initial conditions within the ranges that observation supports. The result, consistent across thousands of runs, doesn't match what's there. The solar system your simulations produce doesn't look like the solar system that exists. The simulations generate a rocky inner solar system in roughly the right configuration, a handful of small terrestrial planets inside the asteroid belt. They generate a gas giant region at approximately Jupiter and Saturn scales. But they also, persistently, generate planets in the mass range between Earth and Neptune, between 1 and 4 Earth masses, orbiting in what is currently the inner solar system. Super-Earths, mini-Neptunes. The class of planet that exoplanet surveys have found orbiting the majority of Sun-like stars in the galaxy, the most common planet type in the observable universe. Our solar system does not have any. Every simulation predicts them. Every observation confirms their absence. Here's where it gets strange. The leading explanation, developed across a body of work including the Grand Tack hypothesis and its subsequent refinements, proposes that the early solar system underwent a sequence of events that destroyed whatever inner super-Earths formed. Jupiter, accumulating mass faster than any other body in the forming solar system, migrated inward from its original orbit, spiraling toward the Sun through the disk of gas and material from which all planets were forming. As it moved, it cleared material, destabilized the orbits of smaller bodies, and swept through the inner solar system. Then Saturn formed. The gravitational resonance between the two gas giants caused Jupiter to reverse direction and migrate outward, a reversal. The hypothesis names the Grand Tack for the sailing maneuver of turning against the wind. During the inward phase, Jupiter appears to have gravitationally destabilized and ejected the super-Earth-scale planets that had already formed in the inner solar system before Earth existed. The simulations produce them. They are not here now. Jupiter's migration is the mechanism. The evidence is indirect, but the inner solar system's emptiness at large rocky planet sizes is itself the evidence. In a galaxy full of super-Earths, we have none. Something removed them before we arrived. What this means, taken to its full implication, is that Earth formed in the aftermath of a destroyed predecessor generation of planets, worlds that formed before Earth, potentially large enough to have thick atmospheres, geological complexity, and liquid water oceans, gravitationally ejected into interstellar space or destroyed in mutual collisions during Jupiter's early orbital migration. The debris from those impacts seeded the asteroid belt. Some of it contributed to Earth's own formation. The period when this occurred, called the Era of Instability, lasted tens of millions of years and left almost no geological record, because the worlds that would have preserved it were destroyed. Saturn's hexagon that geometry can't fully explain, Pluto's heart driving weather on a world declared dead, Enceladus erupting its ocean into empty space. Europa, waiting beneath 4 billion years of ice, the gravitational shadow of a planet no telescope has found, the interstellar visitor that accelerated and left, the disputed lakes under Martian ice, the clouds of Venus that may have answered a question before the data was taken away, the thermally stable shafts in the moon leading into tunnel systems nobody has entered, and now a missing generation of worlds that existed before us and were removed. The solar system is not a solved problem. It is a record still being read, most of it still sealed, waiting for instruments and patience. If you want to keep finding out, subscribe. Leave a comment with which of these you think about most, and tell us where you're watching from.